Hello students, let us continue the session on coordinate geometry. In the previous session, we have learned section formula. In today's session, you will be learning area of triangle. Let x1, y1, x2, y2 and x3, y3 be the coordinates of the vertices A, B, C of a triangle ABC. We need to find the area of the triangle in terms of the coordinate. I have taken the triangle in a Cartesian coordinate system. Point A has coordinate x1, y1. Point C has coordinate x3, y3. Point B has coordinate x2, y2. For the purpose of proving, I have drawn AL, BM, CN perpendiculars from ABC respectively on x-axis. Then by the definition of geometry, we have OL equal to x1 units, OM equal to x2 units, AL equal to y1 units, BM equal to y2 units, Cn equal to y3 units, and On is x3 units. Therefore, the length of LM will be OM minus OL, which is x2 minus x1. Similarly, the length of NM will be equal to OM minus ON. OM is x2, ON is x3. And the length of LN will be equal to ON minus OL. ON is x3 units, OL is x1 units. Since there's a trapezium formed over here, we can make use of the area of the trapezium. We have learned that area of trapezium is half into sum of the parallel sides multiplied to the perpendicular distance between them. Therefore, when you observe it properly, you will come to know that there are two trapeziums here. I'll highlight those two trapeziums. This is the trapezium 1. This is the trapezium 2. For these two trapeziums, we can make use of the formula half into sum of the parallel sides multiplied to the perpendicular distance between them. When we add these two trapeziums, we have an area of the triangle included in that. So, observe properly, the area of the triangle ABC will be area of the sum of the areas of these two trapeziums minus the area of the trapezium ALMB. Area of triangle ABC will be equal to area of trapezium ALNC plus area of trapezium CNMB minus the area of the trapezium ALMB. So let's use the concept. I have taken the same figure again. So sum of the areas of those trapeziums will be half into sum of the parallel sides. AL and CN, they are the parallel sides, and the perpendicular distance is LN. Same way, the sum of the parallel sides is CN plus BM, and the perpendicular distance is NM. Minus, these two are area of trapeziums added, minus area of trapezium ALMB will be AL plus MB are the parallel sides, sum of the parallel sides, half into AL plus MB into the perpendicular distances LM. We have defined the length AL, NC, LN, CN, BM, NM, AL, MB and LM in terms of x1, y1 and so on. Let's substitute that. We get half multiplied to y1 plus y3 into x3 minus x1 plus half y3 plus y2 multiplied to x2 minus x3 minus half y1 plus y2 multiplied to x2 minus x1. We need to simplify this. If you observe, half is being common in all these three terms. This is the first term, this is the second term, and this is third term. If half is taken common, we get we have to multiply the terms over here. On simplification, we get x1 y2 minus y1 x2 plus x2 y3 minus y2 x3 plus x3 y1 minus y3 x1. I urge you to solve this and then check it. Here in the next step, what I'm going to do is I'm going to combine the like x1 together, x2 together and x3 together so that I can take common. If x1 is taken common, I'll be getting y2 minus y3. x2 taken common, I'll be getting y3 minus y1. Next, x3 taken common, y1 minus y2. How to remember this formula? You observe, in all the terms we have something like this, x multiplied to y minus y term. If I consider the numbers here 1, 2, 3, the next number had to take as 2, 3, 1, next had to take it as 3, 1, 2. What do you observe? If 1, 2, 3 are there, it is there in this cyclic order. 1, 2, 3. If you start from 2, 2, 3, 1. If you start from 3, 3, 1, 2. So it's easy to remember. Half should be considered and it should be multiplied to the sum of the terms over here. Note that area of the triangle ABC can also be expressed in this manner. It is in terms of y now. Y1 multiplied to x2 minus x3, y2 multiplied to x3 minus x1, y3 multiplied to x1 minus x2. Their sum is multiplied with half. This will also be the area of the triangle. The above expression for the area of the triangle ABC will be positive if the vertices A, B and C are taken in clockwise direction as shown in the figure here. If it is taken in the clockwise direction, sorry, it is in the anti-clockwise direction, the area of the triangle will be positive. The same thing if you consider in a clockwise direction, the area will become negative. However, in either cases, the numerical value of the expression would be same. We call the same as absolute value. The absolute value of the areas will remain same. Therefore, the area of triangle can be expressed as x1 multiplied to y2 minus y3, x2 multiplied to y3 minus y1, x3 multiplied to y1 minus y2 modulus. This modulus will give the absolute value. So remember, the absolute value would remain same. Look at this The following shortcut method is often used to find area of the triangle. Write in 3 rows the coordinates x1, y1, x1, y1, x2, y2, x3, y3, then followed by x1, y1. Now take the sum of the product of the digits as shown in the down arrow, and from this sum subtract the sum of the products of the digits shown in the arrow which is directed towards upside. The required area of the triangle ABC will be half the difference obtained here, x1 y2 plus x2 y3 plus x3 y1 is being added minus x2 y1 plus x3 y2 plus x1 y3. When we take the absolute value of the difference and multiplied with half, we will get area of the triangle ABC. This shortcut method also can be used in finding the area. Now we have covered the main topics of this chapter. With this knowledge, we can start solving the exercise question. In today's session, we will be solving exercise 7.1. Let's begin with the exercise 7.1. The first question is related to the distance formula. Find the distance between the following pairs of points. First one is 2, 3, 4, plus 1. So we need to use the distance formula. The distance is given by square root of x2 minus x1 the whole square plus y2 minus y1 whole square. So using this distance formula, we will now find the distance between these 2 points. I'll call this point as A, this point as B, this as C, D, E, F. Alright. Now I'll be finding the distance AB. The distance AB will be equal to under root 4 minus 2 whole square plus 1 minus 3 whole square. What is 4 minus 2? It is 2. 2 square is 4 plus 1 minus 3 is negative 2. Negative 2 squared will be 4. So we get root 8 same as 2 root 2. So 2 root 2 units is the distance between the point A and point B. This is the first one. For the second, I have named it as CD. So the distance will be equal to negative 1 minus of minus will become positive 5 square plus 3 minus 7 whole square. Negative 1 added to positive 5 will be 4. 4 square is 16 plus minus 3 minus 7 will be negative 4. Negative 4 when squared will be 16. So we get root of 32. We know that 16 2 times is 32. 16 is a square number, so we get 4 root 2 units. And the third one, I have named it as EF. So the distance EF will be equal to negative A minus A whole square plus minus B whole square. Negative A minus A will become minus 2A. When you square it, it becomes 4A square plus the same way 4B square. Now you see 4 is being common. I'll take root of 4. Root of 4 is nothing but 2. Root Remaining is a square plus b square units. Let's solve second question. Find the distance between the points 0, 0 and 36, 15. Can you now find the distance between the two towns A and B discussed in section 7.2? What is this section 7.2? It is nothing but the distance formula. Now let us find the distance using the distance formula. Here P 0, 0, the point P 0, 0 and Q 36, 15, the distance will be PQ. It is given by root of 36 minus 0 whole square plus 15 minus 0 whole square. So we get 36 square, which is 1296, plus 15 square, it's 225. We get it as 1521. 1521 is a perfect square. We get the root as 39. Therefore, using distance formula, root x2 minus x1 whole square plus y2 minus y1 whole square, we can find the distance between the two towns. Question number 3. Determine if the points 1, 5, 2, 3, minus 2, minus 11 are collinear. For the sake of checking whether it's a collinear, I'll name the point as A, B and C respectively. With these coordinates, I'll find out the length of AB, BC and CA. The length of AB will be under root 2 minus 1 whole square plus 3 minus 5 whole square. So we get it as root of 1 square, which is 1, plus 2 square, negative 2 square is 4. We get it as root 5. Let's find out the length of BC. The length of BC will be negative 2 minus 2 whole square plus negative 11 minus 3 whole square. Minus 2 will become minus 4. So when you square it, we get 16 plus this will be negative 14. On squaring, we get 196. We get it as a root of 212. Let's find out the length of AC or CA. The length of CA will be root of 1 minus of minus 2 whole square plus 5 minus of minus 11 whole square. One plus 2 it becomes, so it becomes 9. 3 square is 9 plus 5 plus 11 will be 16 squared will be 256. On adding that, we get root of 265. What do you observe here? The length of AB plus BC will be a root of 5 added to root of 212, and this is not equal to root of 265, which is AC. Therefore, the points A 1,5, B 2,3 and C -2, -11 are not collinear. Fourth question, check whether 5, -2, 6, 4, +7, -2 are the vertices of an isosceles triangle. Again, for the sake of checking whether it's an isosceles triangle or not, I would like to name the point A to be 5, -2, point B to be 6, 4, and point C to be 7, -2 as the vertices of the triangle. With the distance formula, I will find the length of AB, which is 6 minus 5 whole square plus 4 minus of minus becomes positive 2 whole square. We get it as a root of 1 plus 36, which is root 37. The length of BC is root 7 minus 6 whole square plus -2 minus 4 whole square. Again, we get 1 plus 36, which is root 37. Let's also find the length of CA. It is 5 minus 7 whole square plus 2, -2 plus 2 whole square. We get it as root of -2 square is 4 plus 2 and 2 will get cancelled. We get 0 there. We get 2. Here, the length of AB is equal to the length of BC, which is not equal to the length of AC. Hence, the points form an isosceles triangle. It is something like this. The length of AB and BC, they are equal, and this length is 2 units. This is root 37 and root 37. So 2 of the sides are equal, so it's an isosceles triangle. Question 5. In a classroom, 4 friends are seated at point A, B, and C and D as shown in the figure 7.8. This is figure 7.8. These are the points representing the 4 students or 4 friends. Champa and Chameli walk into the class, and after observing a few minutes, Champa asks Chameli, "Don't you think ABCD is a square?" Chameli disagrees. Using distance formula, find which one of them is correct. Is Champa right or Chameli right? We need to find. We need to identify the coordinates of the point A, B, C, and D. Look at the point A. It is at 3 units away from y-axis, so The x coordinate is 3. Let me change color. So the point A represents 3, 4. Similarly, the point D will represent 6, 1. Point C will represent 9, 4. Point B will represent 6, 7. With these coordinates, we need to find whether it forms a square or not. For that, I want the length of AB, the length of BC, the length of CD, and the length of DA, and also the diagonals AC and BD. Because all the sides are equal in two of the quadrilaterals, namely a square and a rhombus, to have a distinction whether it's a square or a rhombus, we need to find the length of the diagonals also. The length of AB is given by root of, using distance formula, it is 6 minus 3 the whole square plus 7 minus 4 whole square. Therefore, it is root of 3 square is 9 plus 7 minus 4 is 3 square, again it's 9. We get root 18, it is 3 root 2. The length of BC is 9 minus 6 whole square plus 4 minus 7 whole square. Again, the differences are 3 each. On squaring, we get 9 plus 9, which is nothing but 3 root 2. The length of CD is 6 minus 9 the whole square plus 1 minus 4 the whole square. We get again 9 plus 9, which is 3 root 2. The length of DA is 3 minus 6 whole square plus 4 minus 1 whole square. Once again, we have got root 9 plus 9, 3 root 2. Since all the sides are equal, it can be a square or it can be a rectangle, rhombus. To have a distinction whether it's a rhombus or a square, we need to find the length of the diagonal. AC will be 9 minus 3 whole square plus 4 minus 4 whole square. We get a root of 36 plus 0, which is 6 units. The length of BD is a root 6 minus 6 whole square plus 1 minus 7 whole square. We get it as a root of 0 plus 36. We get it as 6. Since AB equal to BC equal to CD equal to DA, as well as AC equal to BD, therefore ABCD is square. Therefore, Champa is right. Our Champa is correct. Question number 6. Name the type of quadrilateral formed, if any, by the following points. Give reason for your answer. There are 3 sub questions here. Let us take one by one. For each of the cases, I would like to take the points as A, B, C, D, so that it becomes easy for calculation. I'll take this as A, this as B, this as C, and this as D. Now I'll find the length of AB. The length of AB will be 1 . Minus of minus is positive 1 whole square plus 0 plus 2 whole square. We get the length as root of 4 plus 4, which is 2 root 2. I'll find out the length of BC. It is negative 1 minus 1 the whole square plus 2 minus 0 square. We get it as root 4 plus 4 again, which is 2 root 2. Let's find the length of CD. CD will be equal to root negative 3 minus of minus is positive 1 square plus 0 minus 2 whole square is root 4 plus 4, which is 2 root 2. Let's find the length of DA, which is negative 1 minus of minus is plus 3 whole square plus negative 2 minus 0 square. Again we got the same length. Here all sides are equal. So quadrilateral may be a square or rhombus. To have a distinction between whether it's a square or a rhombus, let's find out the length of the diagonals. The length of AC will be 1 plus 1 whole square plus 2 plus 2 whole square. We get this is AC, right? Minus 1, all right, minus 1. So we get 0 plus 16, root 16 is 4. The length of BD is negative 3 minus 1 the whole square plus 0 minus 0 square. We again get root 16 plus 0, which is 4 units. Since AC is equal to BD, the diagonals are equal, therefore ABCD is a square. Next sub question, I'll again consider the points to be ABCD respectively, ABC and G respectively. Let me find out the length of AB. What is the length of AB? It is root of 3 plus 3 whole square plus 1 minus 5 whole square is root of 36 plus 16. We get root of 52. 4 multiplied to 13 is 52, so 2 root 13. Let's find out the length of BC. It is root of 0 minus 3 whole square plus 3 minus 1 whole square. We get root 9 plus 4, nothing but 13. Let's find the length of CD. It is root of minus 1 minus 0 whole square plus negative 4 minus 3 whole square. We get root 1 added to 49, which is root 50. 50 can be expressed as 25 times 2, so 5 root 2 we get. Let's find the length of DA. The length of DA is root minus 3 plus 1 whole square plus 5 plus 4 whole square, which is root of 4 added to 81, which will be root 85. Let us find the length of the diagonal AC. It is 0 minus of minus is plus 3 whole square plus 3 minus 5 whole square. We get root 9 plus 4, which is equal to root 13. Let's find the length of BD. It is root minus 1 minus 3 whole square plus minus 4 minus 1 whole square. Root of 16 added to 25 is root 41. Here, observe all the sides here. They are all different. Do we get a quadrilateral? No, we won't get it as a quadrilateral. What's the reason? Carefully observe here. The length of AC added to the length of BC, we are getting the length AB. It means the point C lies between A and B, lies between AB. This implies that the points A, B and C are collinear. So there is no chance that a quadrilateral is formed. Therefore, the quadrilateral ABCD is not possible. Third sub question. Again, I'll name the points as the letters A, B, C, D. Now I like to find the length AB is root 7 minus 4 square plus 6 minus 5 square, which will be a root of 9 plus 1, nothing but root 10. I'll find the length BC will be root 4 minus 7 whole square plus 3 minus 6 whole square. We get root 9 plus 9, which is root of 18. The length CD will be root 1 minus 4 square plus 2 minus 3 whole square. It will be root 9 plus 1, we got root 10. Let's find the length of DA, which is root of 4 minus 1 square plus 5 minus 2 whole square. We get root 9 plus 9, which is root 18. Here, observe the opposite sides, they are equal. Since opposite sides are equal, it can be a parallelogram or it can be a rectangle. To justify that, we require the length of diagonals. Let me mention that since opposite sides are equal, the quadrilateral may be a parallelogram or a rectangle. So let me find the length of the diagonal AC, which is root 4 minus 4 whole square minus or plus 3 minus 5 whole square. We get root 0 plus 4, which is 2 units. The length BD is root 1 minus 7 whole square plus 2 minus 6 whole square. which will be a root of 36 plus 16, which is root 52. On simplification, we get 2 root 13. Hence, we have the result AB equal to CD, BC equal to AD, and the diagonals are not equal. Therefore, ABCD is a parallelogram. It can't be a rectangle. Question 7. Find the point on the x-axis which is equidistant from the point. Let me mention the name as AB. Point A 2, minus 5 and point B minus 2, 9. So let me consider that point. Let P x, 0. Why x, 0? Because it is on the x-axis. P any point on x-axis which is equidistant from point A 2, minus 5 and point B minus 2, 9. Therefore, we have PA equal to PB. The distances are equal. Let's find, using distance formula, the length of PA and PB and equate them. This implies a root 2 minus x whole square plus minus 5 minus 0 whole square equal to root of minus 2 minus x whole square plus 9 minus 0 whole square. Let's simplify this. We get 4 plus x square negative 4x plus 25 equal to root 4 plus x square plus 4x plus 81. Let's square on both the sides so that the root they get cancelled. Then we get 4 plus x square plus minus 4x plus 25 equal to 4 plus x square plus 4x plus 81. Observe here, x square getting cancelled, 4 also get cancels. We'll be getting 8x equal to minus 56. So x value is minus 56 by 8, which is minus 7. Hence, P minus 7, 0 is the point on the x-axis which is equidistant from the points A and B respectively. Question number 8. Find the values of y for which the distance of the point P 2, minus 3, Q 10, y is 10 units. It means that the distance PQ is 10 units. Let's find, using distance formula, PQ. It is 10 minus 2 whole square plus y minus of minus is plus 3 whole square equal to 10. Let's simplify this. We get root of 64 added to y square plus 9 plus 6y equal to 10. Let's square on both the sides. We'll be getting 64 plus y square plus 9 plus 6y equal to 100. We are getting a quadratic equation. Y square plus 6y, on simplification it becomes minus 27 equal to 0. How do we simplify this? This can be the combination of 9 and 3. So positive 9 and negative 3 will give negative 27. So y common, y plus 9, minus 3 common, y plus 9 equal to 0. We get the value of y as negative 9 or positive 3. So there can be two values of y. Question number 9. If q 0, 1 is equidistant from p 5, minus 3 or x, 6, find the value of x. Also find the distances QR and PR. Since q 0, 1 is equidistant from p 5, minus 3 and r x, 6, we have the relation QP equal to QR. Let's find the distance QP. It is root 5 minus 0 the whole square plus negative 3 negative 1 square, which is equal to root QR is root x minus 0 square plus 6 minus 1 whole square. Further simplify, we get 25 plus 16 taken under root equal to root of x square plus 25. Take square root on both the sides, we get 25 plus 16 equal to x square plus 25. The 25 get cancelled, we get x as plus or minus root 16. So x value is positive 4 or negative 4. Alright, if the value of x is positive 4, the length of QR will become root 4 minus 0 whole square plus 6 minus 1 whole square. We get it as root of 16 plus 25, which is root 41. The length of PR will be a root 4 minus 5 whole square plus 6 plus 3 whole square. We get it as root 82. Same way, what if the value of x is negative 4? What will be the length of QR and the length of PR? I want you to find. This you can try. Let's solve one more question. This will be the last question of the session. Question number 10. Find a relation between x and y such that the point x, y is equidistant from the point 3, 6 and minus 3, y. Let me consider the point to be a letter P. X, y is equidistant from, I'll name the point as AB. So 3, 6 is point A and negative 3, 4 is point B. Since it is equidistant, I can say that PA is equal to PB. So what is PA? It is root of 3 minus x whole square plus 6 minus y whole square, which is equal to root of negative 3 negative x whole square plus 4 minus y whole square. we get root 9 plus x square minus 6x plus 36 plus y square minus 12y equal to root of 9 plus x square plus 6x plus 16 plus y square minus 8y. Take a square on both the side. Here x square and y square both they get cancelled. What will be left out will be negative 12x minus 4y equal to negative 20. We can divide throughout by negative 4. We get positive 3x plus y equal to 5. This will be the relation between x and y. It forms a linear equation. 3x plus y is equal to 5. With this, I'll end today's session. In the next session, we shall solve exercise 7.2. Thank you.